Okay, now we're going to talk about the other three things you will learn as we talk about attributes and functions. So you should be able to determine whether a function is positive or negative within a given interval. You should be able to also determine whether a function is increasing or decreasing within a given interval, as well as determine whether a function is continuous or discrete. So if after this video you can't do those three things, there's an issue and I will need to see you at tutoring. So the function is increasing where the y values are getting larger from left to right, and the graph rises from left to right. Now the function is decreasing where the y values are getting smaller from left to right, the graph falls from left to right. So make note of that on your paper. Now the other thing, that's okay, if you didn't get enough time, just go back and pause it. The other thing is you're going to write increasing and decreasing intervals using the domain. You're always going to use your x value for that interval. You're going to use the x value. Make sure you get that. Now, increasing and decreasing intervals are always exclusive at the end. Because they're exclusive, that means there's always going to be parentheses. So now let's actually work some. So if you look at this on your paper, you'll see, and if I were to ask you the increasing or decreasing, you'll see that it's doing a little bit of both. It's decreasing on this side, but it's increasing on that side. So now it's important to be able to tell what that interval specifically is. What that interval is where it's decreasing and increasing. So if I look at this midpoint here, I can see that that's about 2.5, right? That middle point right here, my vertex. So I know that it's doing one thing this way from 2.5, and it's doing something else in the other direction from 2.5. So this is going from 2.5 to negative infinity. This is going from 2.5 to positive infinity. So what would it look like if I was to focus on my increasing? If I were to focus on my increasing, I would focus on that little portion there, correct? And I can see that that is increasing from 2.5 to infinity. And because that 2.5 is in the middle, guys, it's going to be a parenthesis whenever you're talking about your intervals. So it's going to be from 2.5 to infinity, which makes our decreasing what? That section right there, which you should have put negative infinity to 2.5. Hopefully everybody got that. So let's look at another one now. So now I have another one, but now you notice my endpoints are different, right? Because I'm not just going into infinity. So now you question whether or not I'm going to have a bracket. Go back to the page where it talks about intervals. Increasing and decreasing intervals are always exclusive of the endpoints. So you always use parentheses. So those of you that look at this and thought, okay, I'm going to use brackets, be careful. So I can see I'm starting at 2 now. So if I look at my increasing and decreasing, I know that I'm increasing from that point to that point, which would be 2 to 7. Why is it parentheses? Because it's always parentheses because we're talking about increasing and decreasing. So if I'm looking at decreasing, I'm going to have from that point to that point, which is going to be a negative 3 to 2. So make sure you understand that and know the difference. So now we have another problem. Now if you look at this, you'll see that I'm increasing here, I'm decreasing here, but I'm increasing here. And that's okay. So I want you to pause the video and take a moment and see if you can work it. So when I look at my increasing and decreasing, I see that I'm increasing at this point and at that point. So when I go to write that intervals, it's from negative infinity to 3. Any questions about it being negative infinity to 3? But is that the only point? So if I was to go on and write the other one, I would also include 1 to infinity. So now we're going to deal with the decreasing value, which is right there in the middle. So what am I decreasing from? I'm decreasing from negative 3 to 1. Good job. Now, positive or negative intervals are notated using the domain for the interval. So once again, when we're talking about positive and negative, we're using our domain. So since 0 is neither positive nor negative, if the interval ends where an y value is 0, that point is excluded. What does excluded mean? That's correct, parentheses. Now the function is, it's okay if you weren't finished, just go back and pause. The function is positive where the y values are positive, which means the function is negative where the y values are negative. Be careful now, because now we're talking about quadrants, right? This is my positive quadrant. This is my positive quadrant. So because this is all in this quadrant, can I assume it's going to be positive? So that's what it's talking about when it's talking about positive, negative. So everything's positive. So you see how everything was purple? Because I don't have anything that's not positive. So when I go to write that, I'm going to have negative infinity to positive infinity. And there's no negative. So it's an empty set for negative. So now let's look at this graph. Because now I have some, if I'm looking at positive parts, my positive and negative, my positive is going to be on top, right? It's going to be over my, excuse me, my x-axis. So that's going to be positive. And if it's below my x, it's going to be negative. So I know I'm positive from -3 to 0, right? From this -3 point all the way to 0. But I'm also positive from 4 all the way to 7. So now I'm going to look at my negative point. So I notice that I'm negative from something to something, from what point to what point? So it looks like 0 to 4. That's correct. And remember, I'm using parentheses here because I'm talking about positive, negative. But because my 7 ends here, that is still a bracket because I know that 7 is included in that. So don't forget that. Now remember what we talked about. So if this is something you have a question of, you should have color-coded it on your paper so that you could ask the question. So make sure you did that as well. So I want you to go ahead and work the next problem. Take a moment. Pause your video if you need to. So my positive points are up over the x-axis, but you see this little point here? Don't let that confuse you. So I'm going to have negative 4.5 to 1, but I'm also going to have 3 to infinity, to positive infinity. So when I'm looking at my negative point, I'm going to have those 2 points up under there. So I got to take into account I got negative infinity to negative 4.5, but I also have negative 1 to 3. Good job if you got that right. If not, just make sure you ask the question in class tomorrow. So now they want me to identify the domain and range of the given relations, then represent the relation using a graph and a mapping diagram. So y'all are usually pretty good at this. So you're just going to use your mappings. So I know that my domains are my x values. So I have -2, 1, 3, and -4. Remember, we always put them in the correct order. And then my range are my y values. So I'm going to have -3, -1, 2, and 3. So then I'm going to actually graph those points. And then I'm going to do my mapping. So in my first one, I'm going to put my x values or my domain. And then in my next one, I'm going to put my range. And then I'm going to connect each one with the correct one that they go. Any questions over that? Okay, so we're going to now talk about, okay, it wants to know if this one is a function. And how do you know if it's a function? Remember, we talked about that in class. It is a function if x's don't repeat. So do I have any x's repeating themselves? No, I don't. So it is a function. Is it a relation? It is definitely a relation because it does not have to be function to be a relation. So now we're going to talk about the use of discrete and continuous. So discrete function consists of separate unconnected points in the plane. So it's separate, unconnected. It's just like data. It's like dots. Whereas continuing functions consist of an unbroken line or curve or unbroken portion of a line. It doesn't have to go off into infinity. It just has to be a portion of a line or a curve. So if I want to graph the function of 1/2 x plus 1 for the given domain, and I want to figure out if it's discrete or continuous. Remember, discrete points for the domain are unconnected points. So when I look at this data of the domain, that's unconnected, so that would be discrete. So it wants you to create a table with the given domain values, and that's what they did, and they figured out the y values, and then plot the points.